Good afternoon and welcome to the 29th annual exhibit of hydrogen fuel cell technology. It's been a long road. I invite you all to have a seat. The drinks are on the house and the hostesses will be serving them. It's great to have some H2O when we're talking about hydrogen in such detail. Have you ever wondered how people meet and create and expand their conceptions? Every once in a while you have to ask the people who actually network. The people who call on the phone, the people who sit in rooms together and scratch their heads and figure out how best to do things and actually have expertise and come up with something. I'll be talking to an example of this type of creating innovation through cooperation. That is, I'll be talking to Gerd-Dieter Krieger, who is Managing Director of VDMA, the Fuel Cell Working Group. And Dr. Ludwig Jörissen to the far left here. He is Center for Solar Energy and Hydrogen Research at SZW. We'll figure out more about these organizations, but please welcome my guests. So, Gerd, networking. Tell us a little bit about V. I always think of the translation and I always mess it up. VDMA, it's a classic, isn't it, for German? It's Verband der Deutschen Maschinen- und Anlagebau.
Thank you, Brian. I'm just seeing my general manager walking past, so I think he would not so happy if he realized that VDMA is not so well known. But I think we are well known. We are more than 125 years old. But I don't want to speak on VDMA today, but on our fuel cell business, which is already also 20 years old. And I've just heard from my colleagues that we have now more than 90 members. Which is quite good. We are growing with the community, with the trade show. You said I'm really happy to be here. And I'm really happy to be here the second year. Last year, when I was here with our president, Manfred Steffner, we present the innovation cluster, which is a supported project from the German Ministry of Digitalization and Transport. And today we are here to present first results of this innovation cluster, which topic is to bring forward industrialization of stack production. I'm quite happy to be here and present first results together with Dr. Jörissen.
Mm-hmm. Yeah, Ludwig, tell us a little bit about SZW, where you're located and what you people do.
Well, ZSW is a research organization initiated by the Ministry of Economic Affairs in the state of Baden-Württemberg in the southern part of Germany. And we're around since basically 1988, and we're working in the field of fuel cells since 1990, covering the span from fundamental research, which is more or less my topic, to fuel cell stack design and fuel cell testing, system integration, stuff like that. Also, we were founded in the field in the general topic of renewable energies, harvesting, storing, and making it happen.
So I already, my take on what you personally do is this concept of cooperation, largely. How do you explain the innovation cluster to people who don't know what you do and what organization you represent? What exactly do you do?
To get the production forward, we must bring together all people along the value chain. That means component manufacturers, stack manufacturers, system manufacturers, but also the companies who have production know-how. And it's not so easy, but we did it since 20 years, and I think the growing numbers of members shows that all realize that they have to share knowledge, that they have to work together, that they have to create, to solve the problems they have, and they can only solve these problems when they speak and talk with each other. And that's behind our work since the beginning. We have had our General Assembly end of February with 80 companies, and it's so huge, and it's so good when you see the people come together and have the same problem and want to solve it, and that's behind our work. It sounds easy, but in the everyday business, it's sometimes also complicated, but I'm quite happy how far we come now, and I think with the innovation cluster we can go a bit forward. When we was here last year, it was June because of Corona. Now we are again in April. I think last year it was not so clear that we have again personality meetings, but our first meeting then end of June, there were 60 companies there, and it was great to see when people met personally. It's a totally other atmosphere. That's also behind trade shows, but that's also behind innovation cluster and the association work.
We were also very worried about the future of our business model. We thought maybe after Corona, people would do things online all the time. Despite the fact that it was delayed last year, we had record numbers, and this year we've never had such a large exhibit. So this is also, of course, it reflects not us, it reflects on the industry and the things that this industry produces. And I wanted to steer back to that topic. It starts with the smallest components and ends up with very large devices. Ludwig, what you're holding in your hand is a classic example of an object that can be created in secrecy or it can be the product of shared knowledge. Can you explain a little bit about what you're holding there?
Well, what I'm holding here is a bipolar plate, which is the result of a joint effort with a group in the VDMA, designing an automotive stack that's more or less in the public domain, which is open access. So what we did is to develop a high-level specification with a bunch of people from the automotive component industry and the automotive industry, see the specification, see, let's say, the dimensions and so on and so forth, and develop it into a part which can be assembled into a stack. And we need these hardware parts to discuss about, and we need these hardware parts to use them in terms of developing production technology, in terms of developing quality assurance methods for manufacturing, in order to learn how to manufacture a fuel cell stack and to improve the manufacturing processes. Well, these types of bipolar plates and components that go into a fuel cell stack, they're available in the community, but they're available typically under non-disclosure agreements. And so it's not so easy to just show it around and give it to people and, let's say, talk openly about designs and about ways how to use it and how to make it.
But I think what's quite important, and I want to point it out again, to bring up speed of production, you need test samples. And there are no tests, and there was no test samples in the market up to now. And now we are quite happy that with the generic stack we have test samples where different manufacturers or different producers of machinery can test their machine, can optimize their machines, and this generic stack is accessible and also performant. That's the other point. It's not only that you have a piece of metal you can use in your machine, you have also to have an industry standard. That's a group, Ludwig Jörissen pointed out, a group of industry companies, a group of automotive companies shared this specification, and that's quite important, I think, which bring us forward.
Now when we're coming from, let's say, designing and from, let's say, validating designs into real manufacturing, we need real pieces to touch and real pieces to work with, and we need it more or less in a way that people can talk about and people can share experience and can share knowledge what to do, how to position, how to grab them. They're pretty, let's say, floppy in a sense. If you move them fast, they start to fly. There's a lot of details to be learned about how to handle these parts and how to stack these parts, how to position these parts, and which kind of precision and which kind of cleanliness is required to get the performance and the endurance that we ask from fuel cells these days.
When I look back at the industry's history, of course, this is not the first bipolar plate I've had the privilege of discussing. And some of the excitement behind bipolar plates is actually missed. Just to give one example, a bipolar plate from a large automobile manufacturer. So it's a manufacturer that has billions and billions of revenue a year. And they have these guys in a room locked up somewhere that do their stuff, and they happen to have materials expertise that have they're applicable to something like bipolar plates and their gaskets, for example. So here you have these people, and of course their expertise is hidden within a large industry. So they're kind of sleeping there, and without networking, you're not going to know. Every once in a while, these companies step forward and say, we get a bipolar plate. But here's the thing, even if they decide to do that, it's not always the case that they say, and by the way, this is how we make it. A typical bipolar plate will have, for instance, a catalyst, and you ask them, so what exactly is the catalyst? And well, that's... so what I'm asking here is it easy to create a product where it's common knowledge how it's manufactured, where you share information rather than trying to keep it an industry secret? It's something that actually I think is inhibiting a lot of growth, where people have products they manufacture and they say, oh, we're not about to talk about how we did it. We'll give you the end product, even if it's only a component within a stack, but they won't necessarily reveal. And this is not what you're doing, Ludwig, is it?
Basically, what we're doing is we will reveal the design of this particular bipolar plate. We will reveal the design of the stack. It will become, let's say, publicly available. And so we hope that by sharing knowledge, we can improve knowledge, and we can even maximize knowledge in the community. So the community needs parts, and the community needs know-how, and that's something we try to do with providing this generic stack to the community.
But your question was, no, it was not easy. And it was an advantage that it was a good time that the colleagues from FVV have a project for a generic stack where they want to find this common specification. That was the starting point. And the second starting point, I think we don't mention it up to now, or only at not in the focus. It is also an advantage that there is a project HiFab, which is in Ulm, and in the scope of this project, it was possible to produce the bipolar plates because a specification is paper. But you can not use a sheet of paper to test if your bipolar machine works well or can stack. It's not so much thicker, but a bit other structure than the bipolar plate. So it was good that there was this generic stack specification. It was good that HiFab opens the possibility to produce. And before we run out of time, I also want to look in the future. That means that's a bipolar plate, but on the booth of ZSW B46, you can also see a stack, because the next level is to make a sample stack as a next project, and it's in the coming. You can see it. It's not full functional in the moment, but we will, or Ludwig Jörissen can say something on this. And that's the next step. And in the end, our target is also to have a sample system where a balance of plant manufacturers can test and optimize their balance of plant components to a performing stack. That's our vision. It can last another year, but I think we will be successful also on this.
But it's basically the idea of open access that gave the kickoff for the HIFAC projects, where first of all our colleagues from Fraunhofer Institute for Solar Energy Technologies in Freiburg and us were cooperating at the hardware side, and where, let's say, VDMA is more or less providing the forum to discuss and to share know-how and to provide hardware to the community. So it's basically trying to enable and to empower the community with publicly available components. And then, for example, a company that has specific know-how, how to handle, how to grip, how to position parts, and companies that have specific know-how, how to inspect parts. Are they defect-free? Are they functioning? Are they aligned well? And so on and so forth. They can now use these parts to test their particular equipment and to showcase their particular equipment, where you can, for example, see there are such and such let's say, particles on top of a certain component, and you can test then, are they relevant for performance or are they not relevant for performance? Are they relevant for endurance or are they not relevant for endurance? So it's kind of an enabler for the community to do things and to offer things to the community.
So I think we get that. I continuously want to return to this idea. First of all, when we talk about generic, the first application of that word in English I think of is drugs. All of a sudden they're less expensive because the recipe is public knowledge. Sharing knowledge makes things less expensive to create. That's one metaphor. The other thing is the open access concept. And the open access concept is kind of interesting. All of this artificial intelligence we're talking about, you know, the guys at NVIDIA created these 260-core processors, and they had no idea how to make them work. So they donated them to research facilities, and they said, all you got to do, guys, is share the code. So most of our artificial intelligence is actually open access code. Is there a way of looking at what you do that makes use of this metaphor? The idea is, in order to have cutting-edge innovation, we have to open up on what exactly is behind this technology. It's been around since, you mentioned, Manfred, I think it's
1838 or something.
1838. That's how long the PEM cell has been around, but we're still making secrets of what they're created with. Is there a viable metaphor there that we can sort of round things up with?
To a certain extent, it's a viable metaphor. In that sense that, let's say, sharing knowledge will help to increase knowledge. There are limits to that. Certainly, if a company makes business out of knowledge, then this is not to be shared among everybody. But in terms of enabling a community to develop know-how and to increase what's known, I think pieces and technology that can be shared are an essential step forward. Basically, if you have people studying engineering at a university and they come from the university, they have a basic understanding on turbo machinery, they have a basic understanding on let's say internal combustion engines and all kinds of stuff, which is where there's a basic knowledge available, which is textbook knowledge to a certain extent. And for these electrochemical machines, we still are in a process of creating that basis of textbook knowledge, including hardware to touch and including hardware to work with.
And that's also the most important point. It's not knowledge, it's also hardware. That is a bit different to open access comparison. It's hardware, and what's important for me, we have to speed up in industrialization. And for this speeding up process, we need hardware, we need samples, we need test samples in different, that is only bipolar plate. We need also test samples for the other components, right, to speed up.
Unfortunately, we're out of time. This is a conversation that should be continued. And we can do this at the booth, B46, where you can find the booth. Is that right?
Yes, right.
Yeah, B46. SZW is there. I've been talking to Gerd-Dieter Krieger, who's the managing director of VDMA, Fuel Cell Working Group, and to Dr. Ludwig Jörissen, who's at the Center for Solar Energy and Hydrogen Research at SZW. It's been a pleasure to talk to you. I'm sure we'll see each other next year. It's every year. Thank you.